we learned about the possible rational zeros, right, of a polynomial function, and how to do the rational zeros test. And so we did the example at the bottom of page 1, and we did the example at the top of page 3. And I think all we got left is the example on the last example 3 on the last page. Everybody who was here, are we in agreement? That's where we're at. Okay. So example 3 says, factor completely and find all the exact zeros of a given polynomial. So we have f of x is equal to x to the fourth minus 5x cubed plus 3x squared plus x. Do this without a calculator. So immediately, you should notice there's no constant term in this polynomial function. And we have 4 terms, and x is in each term. And the lowest power of x, or the term of the lowest power of x is the last one, x to the first. So we can factor out an x from our polynomial. We have x times x cubed minus 5x squared plus 3x plus 1. So 1, 0 of our polynomial function is x equals 0. Right? 0 makes the right-hand side. Put in 0 for x, and the right-hand side equals 0. So now we got to factor this third-degree polynomial. Okay? And we're going to apply the rational zeros test to this third-degree polynomial. Remember, complex zeros come in pairs, okay? And irrational zeros come in pairs. And since this is an odd-degree polynomial, there has to be one rational root. Okay? So, in this third-degree polynomial, 1 is the leading coefficient. And 1 is the constant term. Okay. And so the integer factors of plus 1 are minus 1 and 1, right? Minus 1 times minus 1 is 1. 1 times 1 is 1. So there are only 2 integer factors for the leading coefficient, and there are only 2 integer factors for the constant term. Right? So remember the possible rational roots from page 1, okay, are the integer factors of the constant term divided by the integer factors of the leading term. And in this case, integer factors of the constant term are plus and minus 1, and the integer factors of the leading term are plus and minus 1. And so the possible rational roots for a third degree polynomial, right? Plus and minus 1 divided by plus and minus 1 is plus and minus 1. So the possible rational roots for a third degree polynomial are the numbers 1 and minus 1. Okay? So we got a very small list. So it shouldn't take us very long to find, right, the rational root. So when I put in 1 in for x in our third degree polynomial, I have 1 cubed minus 5x, 1 cubed minus 5 times 1 squared plus 3 times 1 plus 1. And when you do PEMDAS, we need that 1 minus 5 is negative 4, negative 4 plus 3 is negative 1, negative 1 plus 1 is 0. So, x equals 1 is a 0 of our third degree polynomial, which means x minus 1 from the factor theorem is a factor. So our third degree polynomial over here can be written as x minus 1 times some unknown quadratic. Okay. X minus 1 times the quadratic gives you a third degree polynomial. And so to find this unknown quadratic, we divide our third degree polynomial by x minus 1. Because our third degree polynomial is equal to this product. So when you divide both sides by x minus 1, you get our third degree polynomial divided by x minus 1 is equal to the unknown quadratic. Well, we can do that division using synthetic division. So we're going to divide x cubed minus 5x squared plus 3x plus 1 by x minus 1, and that's going to give us the unknown quadratic q of x. So we can do synthetic division. Our c is equal to 1. And now we write out the coefficients of the third degree polynomial to the right. The coefficients are 1, minus 5, 3, and 1. Leave a space, right? Leave a blank row, draw a line. Now do the synthetic division. Bring down to 1. 1 times 1 is 1. Minus 5 plus 1 is minus 4. 1 times minus 4 is minus 4. 3 minus 4 is negative 1. 1 times negative 1 is negative 1. 1 minus 1 is 0. You better get 0 for a remainder, or something's amiss. So, these are the coefficients that go with our unknown quadratic. Minus 1 goes with, it's the constant term, goes with x to the 0, which is equal to 1. Minus 4 goes with x. 1 goes with x squared. So we have 1 times x squared minus 4 times x minus 1 times 1. So our unknown quadratic q of x is x squared minus 4x minus 1. So we can replace q of x over here. X squared minus 4x minus 1. And now we got to factor x squared minus 4x minus 1. Okay. Well, we can't factor that with real numbers. We got to use the quadratic formula. So we set, right, to find the last two zeros, we set x squared minus 4x minus 1 equal to 0. And then we solve for x using the quadratic formula. A is equal to 1. B is equal to -4. C is equal to -1. So x, the quadratic formula, is equal to -b plus or minus the square root b squared minus 4 times a times c over 2 times a. Well, -b is negative of -4. B squared is minus 4 squared. And minus 4 times a, which is 1, times c, which is -1. All divided by 2 times a, which is 2 times 1. So far, so good. So now it's arithmetic. -4 is plus 4. Under the square root, minus 4 squared is 16. And minus 4 times 1 times minus 1 is plus 4. And in the denominator, 2 times 1 is 2. So, what's under the radical is a positive number. So we're not going to have complex roots. We're going to have irrational roots. We have 4 plus or minus the square root of 20 over 2. And 20 can be written as 4 times 5. The square root of 4 is 2, right? So this simplifies. Well, let's write it out. Review is always a good thing. Right, 20 can be written as 4 times 5. And then by the product rule of radicals, this is equal to square root of 4 times square root of 5, and square root of 4 is 2. So we have x is equal to 4 plus or minus 2 root 5 divided by 2. Fraction bars are like division symbols. Division does not undo addition and subtraction. Many of you still haven't learned that lesson. Saw that on the exam on page 1, problem 1. I mean, half the class, third of the class. I don't know. Significant number. Have not learned that lesson. Okay. Division does not undo addition and subtraction. So this is equal to 4 over 2 plus or minus 2 root 5 over 2. So we have x is equal to 2 plus or minus square root of 5. So the 4 roots, or the 4 zeros of our 4th degree polynomial function, x equals 0, x equals 1, x equals 2 plus the square root of 5, and x equals 2 minus the square root of 5 are the zeros. And x minus 1, x minus 2 minus the square root of 5, and x minus 2 plus the square root of 5 are the factors. So the complete factorization of our fourth degree polynomial is f of x is equal to x times x minus 1 times x minus 2 minus the square root of 5 times x minus 2 plus the square root of 5. That is the complete factorization of f of x, our fourth degree polynomial. Any questions on that? So now you have everything you need to successfully complete the web assigned homework due tomorrow night for 3.4.